Hey everybody, you are at the very tail end of radical functions. You're almost ready to take the test. Thank goodness. Gosh, it seems like we've been doing this forever. All right, so today we are talking about the transformations of our radical functions. Again, only looking at square roots and cube roots, so everything that we talk about today will be based upon those functions. So, quick review of things. The a value in the front of your function, if it is negative, if that leading coefficient is negative, it's going to reflect your x-axis. So instead of starting at a spot and curving up and over, it will actually do the opposite. Start at that same point, but reflect it and go the opposite direction, the red color that I drew. If your a value is greater than 1, this is always a vertical stretch, and you saw some of those yesterday where your graph is just like grows super, super fast, goes up really tall and skinny. And if it is a fraction between 0 and 1, then that means you are going to have a vertical shrink. So it's just going to kind of lob over. So the stretch goes like way tall really fast, and the shrink just kind of goes really kind of flat. All right, the next thing we're going to look at is the h value. So your n is your index, is it square root or cube root, but x minus h, that tells you which direction you're going. If it says x minus h, you're actually going to do the opposite, and you're going to move to the right h units, however many that is. Remember, that's what splits up your domain. So it tells you that beginning point for your domain. If you have an x plus the h, again the opposite will tell us to travel to the left h units. And then our last little chunk, our k values, those are flying our kites. Those are always going to do exactly what they say. So positive k is going to go up k units, and a negative k will go down k units. And again, both of these affect your range. All right, so let's practice a few. We're going based upon the parent functions, the square root, cube root, fourth root, nth root, whichever root we want, doesn't matter. All right, so in example 1, we've got two things actually in front of our cubed root of x. The negative tells us to reflect the x-axis. However, the 1/2 tells us to do something different. That actually tells us that we have a vertical shrink. So it's not growing as fast as it normally would. There is nothing underneath the radical to go along with the x, so no shift left or right, but on the outside it does have a positive 6, so that plus 6 tells us to move up 6 units. Okay, I'm going to stick with my color coding. I think it kind of helps. All right, so example 2, 3 times the square root of x minus 1 and then minus 3. So that 3 in the front, there's two 3's, but I'm talking about that coefficient in the front, the leading coefficient. That is greater than 1, so that is a vertical stretch. The x minus 1 under the radical, that always tells us to do the opposite, so we are going to travel to the right 1 unit. And last but not least, the minus 3 at the back end, that does exactly what it says, go down 3, and that'll split up your range. In example 3, we have y equaling negative times the 7th root of x minus 4. Again, don't worry about what root it is. We're not actually going to sketch it. We're just talking about transformations. So that negative in the front tells us that we are going to, again, reflect the x-axis. And in this case, we do have something with the x. So the x minus 4 tells us to do the opposite. Again, we're going to travel to the right, but 4 units this time. And it doesn't have a shift up or down at the back end, so we don't have to worry about that guy. And our last example of these, let's see, we have the fourth root of x plus 5 and then minus an 8. So the plus 5, x plus 5 tells us to travel the opposite direction, go to the left 5, and the minus 8 at the back end, that tells us to go down 8 units. So again, with the x, restricts your domain. With the y added on the outside for your kite, restricts your range. All right, so for each of these, I'm going to put our parent function in, and then we are going to use that critical point from our graph to help us figure out how did we move this graph around, and did it stretch or shrink or reflect or any of that kind of stuff. So the regular parent function of y equaling the cubed root of x starts at the origin, and it curves up and over like so, here and here, down to the left. So that most important point where that curve happens is the point 0, 0. If we match that on our new red function, that critical point that we have, that is the point -4, 5, -4, 5. So that means we have traveled to the left 4 and up 5 units. If you go up 1 to the right 1 or down and to the left 1 to hit another perfect point, then that shows you that's like your slope, so our a value still just stays 1. So our two transformations, instead of starting at 0, 0 as a critical point in the middle where the curve happens, we start at the point -4, +5, so we have a shift to the left 4 and up 5. If you want to write your equation, it would be y equals the cubed root. That a value is just 1, no stretch or shrink. We're going to do x minus the -4, so x plus 4, and then plus 5 on the back end. There you go. A couple more of these. We're going to practice. Don't forget, your functions are always y equals a. I should do that in purple and go with my coloring that I was doing. Color coding. A for that leading coefficient times the nth root of x minus h, and then outside the radical is your plus k. All right, example 2. This is a square root function. So instead of starting at 0, 0 and traveling up 1 over 1, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and taking this particular path, we notice that our new beginning point, so it was at the origin, and we had an a value of 1. I traveled up 1 to the right 1. In this case, our new origin point is at the point 1, -3. So that means we traveled to the right 1 and then down 3. We're going to check our a value. So if I travel up 1 to the right 1, here we go. That's our same a value. So writing the equation for this one, y equals my a value, which is 1, times the square root of x minus h, which will be -1, and then plus k, which will be -3. That a is looking a little sad up there. There we go. All right, so this equation works out to be y equals 1 times the square root of x minus 1, and then outside the radical is -3. So we're not only stating the transformations, but we're also writing an equation. So that way you guys can look at a graph and know where those critical values are going to go, that critical point and that a value. I'll help you match them later. All right, this is another square root function. Y equals, again, not starting at the origin of 0, 0, not having the curve that travels up and over to the right. Instead, this one begins at the point -1, +2. Okay, so if we're at -1, +2, that means that we went to the left 1, and then we went up 2. Okay, so we can kind of fill in some things in our function already. But one thing that's doing is it's definitely flipped upside down. So instead of our a value going up and over 1, now our a value is traveling down, and it looks like this point right here at the point 0, -1, that's our next best point. So we're traveling from that vertex point of -1, 2 down to the point 0, 1. So we go down 1, 2, 3 over 1. So our a value would be -3. Interesting. So y equals our a value, -3. It reflects and it stretches times the square root of x, and then minus -1 becomes +1 under your radical, and then +2 on the outside. And we'll just make a note that our a value equaled -3, so it not only reflected the x-axis, but it also, I'm going to abbreviate, has a vertical stretch of 3. All right, I think we got one more of these and then we're done for the day. Yay, guys. All right, another cube root function, y equals the cubed root of x. Again, this one should start at the origin, travel up 1 and over 1, or down 1 and to the left 1 to hit that first value, first best point that we can have. Oops, I missed that point a little bit. So right now our a value is 1. All right, when we're looking at our new function, our curve is happening at the point -1, +4. So we know that it travels to the left 1 and up 4. The other thing we need to check is that a value. So let's see if we can travel up 1 to the left 1. Nope. Can I travel down 1 to the right 1? No. It looks like it's going about halfway, actually, because it's right smack dab in between. So our a value is going down, so that's negative, and not a full 1 unit, but half of a unit. So this one reflects the x-axis as well as having a vertical shrink of 1/2. So if we write our equation, y equals, I need my a value to be negative because it's flipped upside down, 1/2 because it's growing half the rate, times the cubed root of x minus -1 would be a +1 under the radical, and then a +4 outside. And that's it. Great job, guys. You have finished the entire unit. You can practice worksheet G, G1 or G2, whichever you choose to do. Make sure that you do some of that. Remember, your test has been moved to next week because our Fridays are the catch-up days. So you have today and then Wednesday, Thursday, Friday to help prepare and study and practice and review everything for your test. It's been quite a long unit, so you got a chunk of stuff to review. Hope you guys have a great day.